Let's practice factoring trinomials. Trinomials means there's three terms. 1, 2, 3. We know there's three terms because terms are separated by plus or minus signs. And so what we have here is this expression, polynomial expression, expressed in the form ax squared plus bx plus c, where a, b, c are numbers. This a value is actually 1, and that's why we write how to factor trinomials when a equals 1. But that's taken for granted. So a here is 1, b is 5, and the c value here is 6. We can factor it as follows. When we get a trinomial and this a value is 1, it's pretty straightforward. You could try jumping straight to the answer. So the factored form is bracket, bracket, leave enough room here. Ask the question, what times what becomes x squared? X times x becomes x squared. So we already solved part of the answer. Now the challenge here is to find two numbers that multiply to be 6. What times what is 6, yet adds to be positive 5x. So let me just take back that last statement here. We're just going to focus on the number parts only. So what two numbers multiply to be positive 6, yet add to be positive 5? I'm just focusing on the coefficient of x here. So one way of doing it is to actually write out what times what is 6. Start with the lowest number. 1 times 6 is 6. What else multiplies to be 6? 2 times 3 is also 6. Now we could go further. We could say that 3 times 2 is 6 and that 6 times 1 is 6, but once we reach the halfway point where the numbers start repeating backwards, we no longer have to go beyond this point here. So I'm going to stop right here. So when we look at these two rows, the numbers 1 and 6 and 2 and 3, which row feels like they add to be positive 5? And the correct row would be this one here. The numbers 2 and 3 feel like 5. In fact, we can just finalize the actual signs here. Positive 2 times positive 3 becomes positive 6, correct? And positive 2, positive 3 adds up to be positive 5. So this here is your correct, are the correct numbers we're going to be using. So we have positive 2 and positive 3 as the correct numbers. We can verify this by using FOIL. X times x is x squared. As for the outside, x times positive 3 is going to be positive 3x, and the inside is going to be positive 2x, which adds to be a total of positive 5x. And finally, the last is going to be positive 2 times positive 3 indeed is positive 6. So we verify that as we expand this using FOIL, that we do get this polynomial, this trinomial. So this indeed is the factored form. Excellent. So now it's your turn. Try a slightly different one with a little bit of a bigger number using the same technique. We see this is a trinomial and the coefficient's 1, so we try attacking the answer directly. What times what becomes x squared? We have x times x is x squared. Now the challenge is to find two numbers that multiply to be 20, yet add to be positive 9. You can try doing it in your head, but if it's a bit daunting, we can try listing the factors. What times what is 20? 1 times 20 is 20. So when we look at these two numbers, how far apart do they feel from positive 9? It feels quite far apart. So let's try 2 times 10 is also 20. And it still feels like it's not generating 9. So I'm going to keep going here. Using your calculator, you can play around with numbers, keep dividing to see what 20 can be divided by nice and evenly. And then what times what is 20? 4 times 5. 4 times 5 indeed is 20, and 4 and 5 feels like positive 9. In fact, if you think about it, positive 4 times positive 5 is positive 20, and these numbers add to be positive 9. So I'm going to drop these numbers in. Positive 4, positive 5. You should FOIL it out. X times x is x squared. This here, using FOIL, is 5x, and the inside is 4x, which gives you 9x. And positive 4 times positive 5 indeed is positive 20. So this here is the factored form. So the key to factoring trinomials when a equals 1, this simple type trinomial factoring, is to write these two giant brackets, figure out the first what times what becomes this first part here, and figure out these missing values by asking the question, what times what becomes this value, the C value, yet add to be the middle part. If it's taking too long to figure out in your head mentally, you can always list the different numbers that multiply to be this C value, and systematically work your way to find a number that also adds to be the middle part. And of course, if your intuition says you should skip some numbers, go right on ahead and skip some numbers and save some time.